Okay, so today we're going to be on page 133, and this is going to be central angles and arcs. So we're on page 133. So our objective for today is to use properties of arcs and angles. So we want to recall what a central angle is. So that's an angle whose vertex is the center of the circle. So we have central angle, and then we want to remember what minor arc is. So that's the arc of the circle that measures less than 180 degrees. And then the last one you want to recall is major arc. So that's the arc of a circle that measures more than 180 degrees. So these three terms are what we're going to be using today to answer some questions. So first I'm going to let you guys know about two rules. So the first one is that the measure of a minor arc is the measure of the arc's central angle. And we'll look at an example after I give you our second rule. So our second rule is that the measure of a major arc is the difference between 360 and the measure of the related minor arc. So these are the two rules that we need to be using for this example that I'm going to show you right now. So we have example 1. So we're going to have a circle with a diameter A, B, and a center E. And we're going to have a point C here, and then a point D here. So we're given that AB is a diameter. So the first question that we want to answer is what our semicircle is. So we have this as AB, because our semicircle is going to be half the circle here. So you have a measure of AB. And we're also given that this angle here is 100 degrees. So if AB is the semicircle, we remember in our notes that semicircle measure is 180 degrees. And that's because this makes a straight line here. So we know if this is 100 and we know this has to be 180 degrees, then this angle here has to be 180 minus 100, which gives us 80 degrees. So this angle here would be 80 degrees because we know that this is a semicircle and it has to make the measure of 180 degrees. So now we want to find what the measure, well, we know that the measure of arc, this is our minor arc AC. When we look back at our rule here, we says the measure of a minor arc is the measure of the arc's central angle. So this is our central angle of 100 degrees. So that means that our minor arc here, AC, is also going to be 100 degrees. And that's because of our first rule here. And now C, we want to find the measure of arc CBA. So that's C, B, and A. And this here would be our major arc. So our second rule says the measure of a major arc is the difference between 360 and the measure of the related minor arc. So that means that we're taking the difference of 360 and our minor arc we said was 100. So we do 360 minus 100 and we get 260 degrees as our major arc here, CBA. And our last one we said BC, which we found out by doing 180 minus 100, which gives us 80 degrees. Because we know this is a semicircle and it measures 180 degrees. So these are going to be how you find these using our rules here. So now I'm going to tell you guys about the arc addition postulate. So this is the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So look at an example. So example 2. So we're given the circle here, and we have a point here. This is G, H, E, F. So this measure here is 100 degrees. This measure here is 40 degrees, and this measure here is 80 degrees. So we want to find what G, the arc GE is. So that is saying that the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So if GE is going to be arc GH plus arc HE. So it's the sum of these two adjacent arcs. So that's 40 plus 100, which gives us 140 degrees. Or we can look at arc GEF. So this is GEF. So we're looking at this whole arc here. So it's going to be the sum of all the adjacent arcs. So that would be 40 plus 100 plus 80, which gives us 220 degrees. So it's the sum of the arcs that are adjacent to each other that form this big arc, GEF. So this is how we use the arc addition postulate. So now we're going to just look at one more example. example 3 here. So we're given a circle, and we have point F, E, D, C, and B. So we're given that this arc is 81 degrees and this arc is 135 degrees. And it wants us to find the measure of arc CFD. So we're finding CFD. So this whole arc here. So the first thing that we need to do is we need to find out what this measure of this angle is here. We know that from here to here, this makes a semicircle, and we know semicircles measure to 180 degrees. So this whole thing here has to be 180 degrees. So to find arc CB, we're going to do 180 minus 135. And this is going to give us 45 degrees. So this angle here is going to be 45 degrees because 135 plus 45 gives us 180, which is the measure of a semicircle. Now we can see that this angle here is a vertical angle to this angle. So this would mean that this is also 45 degrees. So now we wanted to find arc CFD, so we're just adding the arcs of CB, BF, and FE together. So measure of CFD is we add 45 degrees plus 135 plus 45 plus 81. And we're going to get 306 degrees for the measure of CFD. So this is also using the arc addition postulate because you're adding the adjacent arcs together that make up the arc that we want to find, CFD. So we found that angle.